Imagine living in a universe where everything you can think of will happen. A universe where your wildest dreams, your fantasies, and worst nightmares play out to their fullest extent, where everything you have ever thought of is happening. Well, this might not be as far-fetched as you think. In fact, you may be surprised to learn, in an infinite universe, this is exactly what's occurring. Infinity is one of the most mind-bending concepts a human can explore. The idea that something goes on forever, without end or limit, challenges our basic understanding of boundaries and existence. It is not only an intriguing thought exercise that has had mathematicians and philosophers stretching their brains for centuries, but it also raises profound questions about the nature of our reality. Does infinity exist only as a concept, or does it have a real physical form in our universe? Can anything truly be infinite, or is it simply a useful mental construct? Exploring infinity invites us to consider endless possibilities, from the infinite size of the universe to infinite divisibility of matter and time. It pushes the limits of logic and invites us into a realm where the common sense often no longer applies, making it a fundamental and fascinating mystery of human thought. It is quite possible that our ancestors explored the notion of infinity as soon as they learnt to count. The realization that when you add something together, this can go on forever is something we discover from an early age. So it's not unreasonable to believe that the human brain discovered and explored this idea early on in its evolution. Just think about a child, yourself as a child, the game of thinking of the biggest number you can, something many board card journeys have been punctuated with. As children, we begin to explore the boundaries of numbers not long after we learn to count. It's an exercise that begins to stretch our young minds to the possibility of just how big things can get. Soon we begin to realize that there is no limit to this, that numbers are infinite. The simple fact that no matter how big a number we can conceive, you can always add one more, points us towards this understanding. Numbers become our first tantalizing glimpse into the possibilities infinity has to offer. I have explored these ideas with my own children, gaining an ever-increasing view into just how big numbers can get. It's estimated that all the atoms in the visible universe add up to a staggering amount. Not surprisingly, the number is estimated to be 10 to the power of 80. That's a 10 with 80 zeros following it. When we come to understand what this number represents, all the atoms in every one of the trillions of life forms on Earth, every atom contained within every one of the hundreds of billions of planets and stars, nebulae and black holes within our Milky Way galaxy, and every atom contained within every one of the hundreds of billions of galaxies in the visible universe, then it truly becomes a number with great immensity attached to it. An astonishingly large number, but by far not the biggest. When we start exploring numbers such as a googol, which is a 10 with 100 zeros following it, just conceive of a number that is bigger than all the atoms in the visible universe starts to make my brain ache. We begin to subtly sidestep into a world outside of the confines of our reality, but they get bigger. Much bigger. A googolplex comes next in the hierarchy of numbers. With a googolplex, we take another massive leap forward. A googolplex is represented as 10 to the power of 10 to the power of 100. Now this is not 10 times a googol. That would be too easy. A googolplex is a number so inconceivably large that there are not enough atoms in the visible universe to write the number of zeros that exists within it. This is where numbers step confidently across the line between reality we live in and what lays beyond it, where numbers become greater than the physical limits we exist within. Just think about that for a moment. The human mind can conceive of a number that cannot actually be contained within the universe we live within. This is a strange land we have now entered into, leaving the world of the possible, the known, and experience behind and entering into a realm of conceptual reality, of the impossible and utterly bizarre. This land we now find ourselves within is a mysterious and haunting place, a land where the concepts we perceive become shadows lurking behind what we thought of as possible. A place so utterly removed from our everyday lives that to enter here is to let go of what anchors us to the familiar and instead grasp onto ideological and wispy tendrils of what might be possible. Wispy tendrils that can easily dissolve in the mist just when you thought you had them in the palm of your hand. It is to accept an almost philosophical and abstract approach to the hard and defined landscape of mathematics and numbers. And yet there is still more distance to go. In this realm we have entered into, a beast skulks in the gloomy topography, a giant so immense and alien it can never be seen in totality, a form of such utter enormity that you can only catch fragments of it as it slides stealthily across the horizon in the fetid twilight. Welcome to the universe-eating monster known as Graham's number. Graham's number, named after Ronald Graham, a mathematician who defined this number when wrestling with Ramsey theory and combinatorics during the 1970s. If you've never heard of Ramsey theory or combinatorics, then I can assure you you are not alone. In short, Ramsey theory is about finding inevitable patterns in large or complex structures, and combinatorics is about counting and arranging things in different ways. Enough said on that. Ronald Graham was working on hypercubes when his number, Graham's number, was first outlined. Hypercubes are used in higher dimensional geometry, theoretical computer science and mathematics. The work on hypercubes is used to describe and quantify four-dimensional shapes, a way of describing shapes that exist outside of our three-dimensional universe. Told you we had left our reality behind. Two things worth mentioning here. One, Graham's number is so large that it can't be written out fully in conventional notation. No surprises there, as we have encountered this with the Googleplex. And two, this is where my ability with words begins to fail, especially when we start exploring hypercubes. Here, yet again, we glimpse the human mind, not mine, stretching beyond the confines of our physical existence and stepping into a realm so utterly alien it can only be described through numerical analogy, philosophical potentiality, and quantifiable possibilities. I think my brain just imploded. I first came across Graham's number in a BBC documentary about numbers some years ago, and yes, this is how I like to pass my time. In the documentary, they concluded that as big and as used as Graham's number is, no one could actually define it wholly. However, they did conclude, with some degree of certainty, that Graham's number likely ended in a 7. What? I watched this documentary with my eldest daughter, who was 7 or 8 at the time, and using genius child logic, she said, "What if we just add 1, Dad?" Oh, how we laughed about the number so enormous you could only see the 7 at the end of it, and how she created a number that was bigger just by adding 1. I'm not sure that's how it works, to be clear. Nonetheless, that 7 at its end and adding 1 to it stuck with us. We still joke about it today, some 12 years later. Got to love its name as well, Graham's number. Such a mundane and ordinary name, no offence Ronald, to such an extraordinary thing. The idea that the human mind can imagine such concepts is, for me and my daughters at least, an idea that is truly full of wonder. An idea that points to just how unimaginably capable the human mind, consciousness, may actually be. Having said all this, one simple fact remains. No matter how big a number the human mind can conceive, no matter how large the idea it can entertain, they are nothing compared to infinity. The notion that something can go on forever may well be beyond what the human mind is capable of comprehending. but let's have a go anyway. To wrestle with the idea of infinity, a couple of examples may serve to help us begin to calibrate our minds into a kind of understanding of what infinity might actually look like. A parable often used to help describe infinity is a story about the infinite hotel. A hotel with an infinite number of rooms. The infinite hotel always has a vacancy, but to operate effectively, when a new guest arrives, the hotel manager asks everybody to pack their belongings and move up one room. Wait, I hear you say. Why not just ask the new guest to go to the end of the corridor and into a vacant room? Well, this is where infinity becomes mysterious, in a confusing and not very practical kind of way. Infinity doesn't work like that. That's how finite numbers work. There is no end room. There is only the ability to keep going forward. So with that in mind, everybody in the hotel moves up one room and the new guest is accommodated. But wait, an infinite number of new guests has arrived, all at the same time. But here again, this is an issue the manager of the infinite hotel can work with. The manager asks everybody to move to a room that is twice the numeric value of the room they are currently in. The guest in room number 1 moves to room number 2, 2 moves to 4, 4 to 8, 8 to 16, and so on. Soon we see that all the now occupied rooms are in even numbers, freeing up all the odd rooms for the new guests. An infinite number of odd-numbered rooms for an infinite number of new guests. And because it's an infinite hotel with an infinite number of rooms, the hotel manager can do this as many times as they need to, accommodating an infinite number of new arrivals an infinite number of times. Bit of a chore for guests in room 1 billion for sure. They've got to move to room 2 billion. Quite a trek. But it is possible. So far, we have been adding numbers to explore the idea of infinity, moving up and onwards, as it were. But the concept goes the other way as well. Also in division. At the Infinite Hotel, the manager likes to inspect all of the rooms, something they can do in just 1 minute. I did say this was magical. But they have a system. The manager spends 30 seconds in room number 1, 15 seconds in room number 2, 7.5 seconds in room number 3, and so on. Yes, they are super quick, but by spending half the amount of time in the next room to the last, they are able to divide that 1 minute into an infinite amount of segments. The trouble is, this goes on forever, so the manager is probably never coming back, even though they will be done in just 1 minute. My head hurts. This is theoretically true with all divisible units. A centimetre to a millimetre to a micrometre to a nanometre, a pecometre, all the way down to Planck length and the quantum level and beyond. In theory, that is. So the idea that numbers go on forever, or that something can be divided forever, is a basic concept when it comes to infinity. Something that has a theoretical place in our world, but not a very practical one. In theory, you could eat an apple and make it last forever if you only ate half of what you had left at a time. But to do this is an impossibility. Soon you would have a piece of apple so small you could not actually divide it in half anymore. And there is no infinite hotel, nor the space in our visible universe to contain it. And there is no hotel manager that could move fast enough to inspect a room in fractions of a second. Our three-dimensional reality just does not accommodate these concepts, neither in time nor space. But then again, maybe it does. A circle is one of the first shapes we encounter as a child. A circle is thought of as a shape with one side. One-sided shape equals a circle, two-sided shape a semicircle, 3 a triangle, 4 a square, and so on. But when we start unravelling the circle, the most simplest of shapes, it soon becomes apparent that it is the very opposite of a single-sided shape. The number pi is a key into this understanding. Pi is used to calculate the circumference of a circle, times the radius of a circle by pi, and you get the circumference, right? The trouble with this is that pi is always used as an estimated number. Pi is a 3 with an infinite amount of decimal places following it. I first came across this in math at school. I was not a very diligent student in any subject, but a couple of concepts really caught my imagination, and pi was definitely one of them. Since I was 14, I've been able to remember pi to 7 decimal places. 3.1415927 rounded up on the last digit. But this number goes on forever. A number you could spend the rest of your life calculating, and your children and your children's children, and not get the complete answer. This is because there is no complete answer. Pi is an infinite number, and because pi is an infinite number, a circle can be thought of as a shape with an infinite number of sides, an infinite number of radii moving out from its central point. So a circle may not be the first shape in the league of shapes, but it may be the last. Or maybe the circle is a shape that brings a 100-sided shape, a million-sided shape, well, full circle, making it the first and last shape in a league table of shapes at the same time. A bit like an ace in a pack of cards that acts as a 1 and a 14, if you follow my drift. And this brings us to another paradox. A simple, if a little mind-stretching way of understanding this paradox is a couple of simple calculations. Infinity plus 1 still equals infinity, right? But what happens if we then subtract infinity from both sides of the equation? You get 1 equals 0, and then we find ourselves with some kind of problem. This is the kind of problem that does not happen in finite arithmetic. When working with infinity, you can write things down that simply don't have an answer, that don't have a complete sense to them, a bit like pi. Maybe the circle's paradoxical and infinite properties are why it has been held in such high esteem by humanity throughout history. The sun, moon, and planets, the human iris, pupil, all seeming to have spiritual connotations. This shape seemingly so perfect in its expression, always having been associated with God, the gods, creation, and perfection. Since the beginning of civilization, well, in its latest iteration anyway, pi has been known and used as a concept. The Egyptians used pi, the Babylonians were thought to have been the first to have known about it. Again, a concept that always seems to have been with us, embedded in the consciousness of our species from its earliest days, so simple and yet literally so inconceivably complex. Maybe something as simple as the circle with its infinite calculability is an expression of the universe itself. The universe in essence attempting to understand itself through an infinite calculation within divine Godhead-like computer, running through time and giving expression to everything we know in creation as a byproduct, as it continues on until the end of time. Better hope it doesn't complete its work anytime soon, I guess. Speaking of which. And then, of course, we have the universe itself, one of the largest thought-provoking and mysterious focal points in any discussion around infinity. Is the universe finite? Does it have a boundary, an edge, or does it go on forever? Either of these scenarios throw further questions into the conversation, each with quite wondrous possibilities. If the universe is finite, what lies beyond it? If it is infinite, well, we'll get to that in a moment. Even cosmologists wrestle with these ideas and have no definitive answers, depending on who you ask, of course. But either view is based on an educated guess at best. The late Stephen Hawking was a proponent of an infinite universe, whereas Neil deGrasse Tyson argues it is unlikely. The jury is out on this one, and always likely will be, particularly if it is infinite. I mean, how would you measure that? Quantify it? Know it? It seems, from our hairless monkey perspective, it is an impossible thing to define, to wrap our arms around it and say, here it is. What we do know is that the visible universe has a diameter that stretches some 93 billion light years across. However, because the universe is expanding, the limitations of light speed mean that anything beyond that visible boundary will always and forever be out of sight to us. The space between us and those regions has expanded so much that the light cannot catch up with us and never will. But what if the universe is bigger than this? Let's face it, the chances are it is. After all, it's not too unreasonable to presume that we are not at the exact centre of the universe. That in itself would be something quite extraordinary, throwing deeper questions about the meaning of life into the mix. It is more likely that the bubble of perceived universe we observe only appears that way due to the limitations already mentioned. Like walking out on a misty day, no matter where you stand, your view is always contained within a certain distance, relative to where you are at any given moment. So the chances are the universe is bigger than we perceive it to be, much bigger. And of course, there is the real potential that the universe may be infinite, that it may go on forever in every direction. Let's explore that idea for a moment. I mean, we have all looked up at the night sky and considered the impossible distances between the stars, right? Pondered over the vast distances involved, and at some point, just how far it might actually go, toying with the possibility of it being infinite. Even if you do not believe the universe is infinite, suspend your disbelief just for a moment, and if only as a thought exercise, entertain the possibility that it might be. What does that mean? What does infinity bring to the table in terms of time and space? When we consider the possibility that the universe may actually be infinite, we very quickly get into the realms of something quite miraculous. If the universe is infinite, then anything you can imagine can and is happening. This is another mind exercise my children and I often play out in a kind of humorous way, usually while walking the dogs. When we do, we quickly conclude that in an infinite universe, if we can think of something, anything at all, we have kind of created it. That whatever we think is happening out there somewhere. No matter how bizarre or ridiculous, whatever it is our imaginations can comprehend, it is happening. A world where everything is the same as here, but people have noses on the back of their heads. A world where the dinosaurs didn't become extinct and evolved into a civilization where they keep humans as pets. A world where eggs have legs and walk to you when you are hungry. A world where you have the ability to teleport, fly, are worshipped as a god. Infinite worlds where you exist living exactly the same life but with minor differences, where you made different choices resulting in different outcomes. It's comforting to know you may be out there somewhere living your best life, and equally terrifying to realise the horrors you may be facing. Indeed, there would have to be somewhere out there a monkey typing the full works of Shakespeare by accident as well as by design. No matter how bizarre, weird or wonderful the things we could imagine are, we soon came to realise that in an infinite universe, they are happening, and then some. This is the power infinity has over space. Equally mind-bending is the idea of infinite time. If the universe goes on forever and has no end of time scenario, then it can expand these possibilities exponentially. Not only is the above true in terms of everything you imagine will or has happened, but there is also another very interesting idea at work. An idea that caught my attention and helped me clarify the power of infinite time is the perfect box scenario. Imagine a box with an apple in it. It's a perfectly sealed box. Nothing can get in and nothing can get out, ever. In this box, given an infinite amount of time, very strange things would happen. The apple would, of course, break down, rot and decay. In a year or two, the apple is likely to be little more than dust. But eventually, the energy contained within the apple's dust, its atoms, its particles, its chemical energy, would be released. It has to. And because of this, the box would become very, very hot. Thousands of degrees, E equals mc squared after all. After a really long time, those atoms will start to fuse together. Eventually, the apple has turned into millions of degrees plasma, containing ion nuclei, photons, etc., just existing within our perfectly sealed box. After billions of years, even neutrons will decay into fundamental particles and just sit there in this state in the box for a very, very long time, potentially trillions of years. But this is where it starts to get extremely weird when an infinite amount of time is at work. If that apple contains 10 to the 24 particles, then those particles can be in 10 to the 10 to the 24 potential different states. And that is a huge number, an incredibly large number of different states those particles can be in. But it's not infinite. Because we have an infinite amount of time on our side, those particles will become each and every one of those different states. 10 to the 10 to the 24 different states. A clock, a candle, a hat, a black hole, a star, a mouse, a cup, you get the idea. But eventually, in our perfectly sealed box, and given an infinite amount of time, those particles will have gone through every one of those 10 to the 10 to the 24 possible configurations of what they can be. They have to. And at some point along that infinite timeline, if you timed it well, you could open that box and find within it the apple. Given an infinite amount of time, every possible state those particles could be, will be, until the apple is there again, just as it was when you placed it in the box. My head just imploded again. This is the power of infinite time. As a parting thought, spend some time, maybe not an infinite amount, considering the possibility of a universe in which space and time are both infinite. I don't know about you, but it's a pretty awesome idea to consider we may live in a universe where this might actually be the case. What are your thoughts? Do you think we live in an infinite universe or a finite one? Do you think infinity is a concept or something that actually exists? Let me know your thoughts in the comments below. I'd love to hear. I hope you have enjoyed our brief exploration of the infinite, and, I suppose, given an infinite amount of time, we could have explored all the ideas and concepts surrounding it. But we don't have an infinite amount of time, so I will put a line under infinity for today. If you have any thoughts or ideas for future episodes, also let me know in the comments below. If you enjoyed today's episode, then please consider giving us a like and subscribe to be kept up to date with new episodes as they are released. I look forward to seeing you again soon as we continue on our adventures into the unknown, the unsettling and utterly bizarre. In the meantime, question everything.